When looking at the distribution of data, we say that data that has most of the values clustered around the mean is called normally distributed. This was once called a bell curve because if you look at it, the shape of it looks like the shape of a bell. So you might have heard that term before. This is often called a bell curve. Now, when we look at this histogram, this point here, this is the mean. And remember, we use that Greek symbol mu to use mean of a population and x with a line over it to mean that's the mean of a sample population. This is the whole population. Okay, what standard deviation helps to describe is where those clusters are around the mean. So if we were to divide this up, this here, I'm going to draw a line here. This is the mean. Now I'm going to divide this histogram into sections. I'm dividing it so that it is symmetrical about the mean. So let's do another one here. And again, the same on this side. We'll do another line here. And let's do one more out here. There we go. Now, what standard deviation helps to describe is the percentage of data that is clustered around the mean. So we'll label this mu for mean. And on this side of the mean, this is one standard deviation. On this side, this is also one standard deviation. It's just one standard deviation back. So one standard deviation on that side. On this side here, looking at these lines, now this is one, from here to here is one standard deviation, and from here to here is one standard deviation. But we say from the mean, this is the mean minus 2 standard deviations. And on this side here, this is the mean plus 2 standard deviations. And going a little bit further out to these ones, again, this is one standard deviation from here to here, and one standard deviation from here to here. So if we look at it from that mean, this is, on the left side, this is the mean minus 3 standard deviations. And on this side, it's the mean plus 3 standard deviations. And so what statistics often says is that between one standard deviation either side of the mean, this is where 68% of the data lies, between those standard deviations. Between two standard deviations, so between here and here, between these sections, 95% of all the data in this data set lie between two standard deviations of the mean. And then the very last one here, between here and here, is 99.7% of the data lie within 3 standard deviations of the mean. And then often this 0.3 on either, or from both sides here, these are often called outliers. And it's typically takes up 0.15% of the data on either side. Outliers on this side. So that's what standard deviation helps to tell us about normally distributed data. So we're going to look at the formulas for standard deviation in an example in the next lesson.